So next we're going to find the graphs of cosecant and secant. And if you recall, we had a table when we were just reminding ourselves what the graphs of sine and cosine were. There was another column for cosecant and secant. We'll go back to those in a second, but I want to remind you that cosecant is the reciprocal of sine, and we're upset about that, so we're sine. But this is 1 over sine, and secant then is 1 over cos. So if we go back to our table, we already have all the sine. If you look back in this graph or find this table, you'll already have all of the sine and cosine numbers put in there. So I've already included them. Now we're going to look at the cosecant. So cosecant is just 1 over sine x. So all we need to do is do 1 over the value that's there. Now it starts off at a really interesting one. If at 0, sine is 0, so it's 1 over 0. We know we're not allowed to have that, so cosecant will have an asymptote, just like the tan curve does in the cotangent curve. But what about sine, or at 15 degrees? Well, it's 1 over 0.2588. Now you can just do that, or if you have the 1 over button on your calculator, you can type in sine 15, get this decimal, and push the 1 over button, and you'll get this number right away. It ends up being 3.8637. Then we're at 0.5. Well, this one I can actually probably do in my head. It's 1 over 1/2, so that's a reciprocal is 2. You can punch that in your calculator and verify that that's going to be 2. And then 1 over 0.707 is 1.414. 1 over 0.866 is 1.1547. 1 over 0.9659 is 1.0352. And then 1 over 1 is just 1. So we end up with this interesting shape. And then, of course, the numbers are going to repeat. So I'm going to let you fill in the numbers here and fill in the rest of the numbers here. And you can pause the video to draw those, or to figure out the rest of those numbers. And then on the page, do a sketch. So I'll just pause and give you a chance to, or you can pause and get a chance to try these, put them on your graph and see what happens. So if we were to actually sketch this, we would start to see some of the information. Now, before I sketch cosecant, I'm actually going to sketch sine first. I think it's good to have that reference. Excuse me. So I've got my scale here, and I'm going to go up by quarters. So 1, 2, 3, 4, there's pi. 1, 2, 3, 4, there's 2 pi. And if I'm sketching sine, I know it starts at, oh wait, I got to pick a scale for my y-axis just so that I'm not crowded. I'm going to go up by every 1. So there's 1, there's 2, -1, -2. And sine, I know, starts at 0, ends at 0, halfway it's at 0. Halfway between these two, it's at 1. Halfway between these two, it's at -1. And if I do a sketch, I get sine. Now I'm going to do this really lightly because I'm not technically sketching sine here. I'm sketching 1 over sine. So I'm just going to do that lightly. I'll use it as a reference. Now when I go back to my chart for cosecant, I can start graphing these green numbers, but the first thing I see is the first green number is this x, this asymptote. So at 0, cosecant, it has an asymptote. So I'm going to draw that asymptote right here. And I'm sure you've discovered that if you've done this, there's going to be other asymptotes. Another one happening at pi, or 90 degrees, or 180 degrees, and then 360 degrees, or 2 pi. And comparing these asymptotes to the original sine curve makes sense. Notice that the original had a 0 here, so 1 over 0 is going to result in an asymptote. There's a 0 here, so 1 over 0 is going to result in an asymptote, and a 0 here, so 1 over 0 is going to be an asymptote. So there shouldn't be a surprise when we're doing the cosecant, and that there's going to be asymptotes. Now I start sketching the rest of it, and again I can go back to my chart and say, well, at 15 degrees it's 3.86, so that's a little bit higher than my graph. Instead, I'm going to start at 30 degrees and 2. So 30 degrees and 2 is going to be, well, here's 180, here's 90, this is 45, so 30 degrees and 2 is roughly here. Go back to my chart, 45 degrees and 1.414, so that's about here. But then I start to realize, oh, and then 90 degrees is at 1, so there's that spot, and then they start repeating. Okay, so we have here and here, and then I start realizing it's going to make this shape, and you probably have already noticed this shape. And again, if I think logically, it also is logical. We already talked about 0, and the reciprocal of 0 is the asymptote. The reciprocal of 1 is 1, so that number is going to be the same. And then as these numbers get bigger, if you reciprocate these numbers are going to get smaller. And then as sine curve gets smaller, the reciprocal is going to get bigger. And then these small numbers end up being really big numbers, and we end up with that shape. Same thing's going to happen down here in the negatives. And then what you have is the cosecant curve being the green one. So when I draw it, if I have to draw it from scratch, I draw the sine curve really lightly. And drawing the cosecant curve, well, I know at the zeros is going to be an asymptote, asymptote, asymptote. I know this spot and this spot are the same because the reciprocal of 1 is that, and then the graph goes like that. And we end up with a graph of cosecant. Now again, I'm going to ask that you pause the video and repeat all of these steps with secant. So you've got that the secant is the reciprocal of sine, or cosine, sorry. So right away, again, this is 1 over cos. So if it starts at 1, guess what? 1 over 1 is 1, so this is 1. And then 1 over 0.9659 is 1.0352. And then 1 over 0.866 is 1.1547. And then 1.414. And then 2. And then I'm going to let you continue on with both of these and ask you to make a sketch for secant over here. So again, you can pause, and then I'll come back and show you what the sketch of secant looks like. So hopefully you've had a chance to sketch secant. I'll quickly go through the process, but I'm not going to use my chart anymore. I'm going to use what I understand about the reciprocal functions. And so I start off with a graph of cosine. Remember, cosine starts at 1, ends at 1, halfway between is at -1, and then it goes down to 0 and then -1, back up to 0, and then +1. So there's my cosine curve to start off with. I should know wherever cosine is equal to 0, here and here, I'm going to get, I'm going to get a vertical asymptote. Just going to fix that one so it's a little bit better. And I know the reciprocal of 1 is going to be 1, so this spot is going to be 1. Reciprocal of -1 is -1, and the reciprocal of this is going to be like that. The bottom half of the middle section of this curve looks an awful lot like the sine function. These are really small numbers, so these are the reciprocals are going to be big, and then as these get bigger, this gets smaller, and I end up with this shape, much like the cosecant curve. And then here, as these numbers get smaller, my reciprocal is going to get bigger. Same thing over here. And I end up with a sketch of the secant curve. So you should now have seen tan, cotangent, cosecant, secant, all the different ones. Recognize that secant and cosecant can all be stretched, flipped, just like sine and cosine, except your starting point is a different picture. So good luck with the rest of the sketches.